Hey everyone, GruffDBA here again, and today I'm talking about cloning Oracle databases with a Dell Powerstore storage array. But first, some boring legal stuff. All copyrights belong to their respective owners. Images and text owned by other copyright holders are used here under the guidelines of the fair use provisions of the US copyright law. Said images and text are used here only for educational purposes and not for making money. Guys, I'm not getting paid for doing this. I'm doing this on my own time. But when I do get paid, I work at Dell. I'm a principal engineer with Dell Technologies. That said, opinions expressed here are my own and do not necessarily represent Dell Technologies or any of its subsidiaries. Okay, let's talk about storage snapshots. In this example, we've created volumes on our Powerstore storage array, and we've used those volumes as ASM disks for an Oracle database. ASM sees the Powerstore volume as an ASM disk and is able to read and write from it as it would any other block device. Here we've written out 4 blocks labeled A, B, C, and D, and they hold the values 1, 2, 3, and 4. A snapshot is when we tell Powerstore to create pointers to the blocks of the source volume. The Powerstore makes a note of where all the blocks are and stores this as metadata. Now, this snapshot can be used to clone the disk group, and it is quite clever. What happens is this. Once the snapshot is created, any changes that occur to any of the blocks in the ASM disk are in fact saved to a different location on the Powerstore, and the original contents are kept intact. This technique is called redirect on write, and this is all completely transparent to ASM. Now, as far as ASM is concerned, our disk has the updated values 6, 5, 3, and 7. Snapshot 1, however, still sees the original blocks 1, 2, 3, and 4. Note that block C with the value 3 is used by both the source volume and snapshot 1, as this block has not changed. And that's a key point. Snapshots only need to store the changed blocks. Blocks that do not change do not need to be preserved with the redirect. If ASM makes further changes to any of the already changed blocks, it does not have to redirect a second time. It simply updates the new block. Unless, of course, we create another snapshot, at which point all of the newly redirected blocks would have to be preserved as well. If we delete snapshot 1, we no longer need to keep the blocks that were preserved for it, so we can discard them, and that storage space is freed up. It should be noted that this approach to making copies of Oracle databases is supported by Oracle. MOS Note 604.683.1 covers the topic, and note the prerequisites it calls out. The database must be crash consistent, and the right ordering must be preserved. So, let's talk about volume groups. In an earlier video, I showed how to create a multi-disk ASM disk group on a Dell Powerstore. Oracle recommends using at least 4 disks in an ASM disk group, and there are clear performance advantages to doing so that we'll cover in a later video. But one problem of using multiple volumes for an ASM disk group is that if we want to create a storage snapshot, how do we snapshot every disk in the disk group? In our example here, we snapshot the disks in sequence, but even moving as quickly as we can navigate the interface, we'd still end up with each disk snapshot at a slightly different time. That would lead to a disk group that is probably corrupt, and the database certainly would not be crash consistent. Volume groups allow us to logically group together all of the disks in the disk group and apply right ordering to all the members of the group. We can then snapshot them all at once. Our snapshot ASM disk group is not corrupt, and the database would be crash consistent. So we definitely want to place all of the volumes of an ASM disk group into a volume group if we want to use storage snapshots on a Powerstore. But what about if the database uses more than one ASM disk group, as many databases do? Remember the MOS note. We need the database to be consistent. All volumes should be snapshot at the same moment in time. So we can add all of the volumes of any other ASM disk groups that the database is using to our volume group. And what about the FRA? Well, in the example I'm going to show you, I am adding the FRA to my volume group because I have one of my database control files in the FRA, and so including it makes my life simpler. But it also means that any archive generated after the snapshot will not be included in the snapshot, meaning I cannot roll my copy forward from the point of the snapshot unless I am willing and able to manually copy the archive logs to my clone. Many DBAs choose to leave the FRA out of the volume group. This allows them to snapshot the FRA a little bit later on, at a time when additional archive logs may have been generated, and then apply them to the snapshot clone. In this later example, just make sure that no control files, redo logs, or data files are located within the FRA. Alright, we've talked a lot about snapshots. Snapshots are a logical collection of pointers to blocks that represent the volumes at a moment in time. But Powerstore does not allow us to directly mount the snapshot to another host or cluster. To actually access the ASM disks in the snapshot, we need to make a thin clone. The thin clone can then be mapped to a host or cluster and mounted in ASM. In fact, you can just make a thin clone of a volume group, which creates an implicit snapshot and saves us a step. Either way is fine, but I am going to show you creating the thin clone directly. So here we are in the Powerstore interface, and we want to create a snapshot clone of our Swingbench database on our Oracle One server. If we scroll through the list of volumes, we need to find the 4 volumes that are the Swing Data ASM disk group. And we're also going to need that FRA disk as well. In order to be able to create a snapshot of all 5 volumes at once, we need to create a volume group. So click Storage, Volume Groups, and then on Create. Now we can create a new volume group. So we'll call it O1 Swing VG for volume group, and we'll give it a description so that we know what it's for. Let's go ahead and click Create. And now we can click Add Volumes to add those 5 disks to our new volume group. So let's scroll down and find our Swing Data ASM disks, and also remember to add that FRA as well. We'll click Apply and we'll add them to our new volume group. Now if we go to the volume group menu, we'll be able to make a thin clone of our new volume group. So highlight the volume group, and if we click Protect, it'll allow us to create a snapshot. But remember, we can also go to Repurpose and just directly create a thin clone. We'll give our clone a name and a description so that we know what it is. Now let's click Clone, and the Powerstore will make a thin clone of our ASM disk groups. If we highlight that thin clone, we can now click Provision and Map to mount the clone on our ESX cluster. So select the hosts or ESX clusters to map the thin clone to, click Apply, and when the mapping jobs have completed, we can switch to vCenter to mount the thin clone to our Oracle VM. So here we are in vCenter, and the first thing we need to do is to rescan the HBAs so that VMware can see the 5 new thin clone volumes. So we'll right-click on Data Center, select Storage, rescan Storage, deselect the Scan for New VMFS Volumes option, as we don't need that, and when vCenter reports that all the HBAs have been rescanned, we can go to our VM and add the 5 new volumes. We will select our VM, select Edit Settings, and then add an RDM disk, and then a list should appear which includes the 5 new volumes. Now vCenter is going to list out all of the disks that it can see, and in our example here it's pretty obvious which are the thin clone volumes. There's 4 800 gigabytes and there's 1 2 terabyte volume. But we can also expand out the path ID and check the WWN of the volumes. So there is 6A9000, and if we go back to Powerstore, we can go into Storage and Volumes and find our thin clone volumes and check the WWN of the volumes there. So as we scroll down here, we should look for Swing Clone. There it is. And once again, we see 6A9000. So we know that we found the right volumes. Let's go ahead and add those to our VM as RDMs. Thanks to the magic of video editing, I've skipped over the tedious part of adding the other 4 volumes, but they are there. So let's go ahead and reconfigure our virtual machine, and then we can log into the guest VM and present the thin clone to ASM. Okay, so let's recap. We have a Swingbench database running on Oracle One, and it has files that use 2 ASM disk groups, Swing Data and FRA. We've created a volume group that comprises all the disks on both of those disk groups. and then we've made a thin clone of our volume group, and we've presented that back to ESX, and we've added the volumes to our Oracle 2 VM. However, we now have a problem. Our Oracle 2 VM already has a Swing Bench database on it. In fact, it already has a Swing Data ASM disk group, and it has an FRA ASM disk group. So we can't mount our thin clone to Oracle 2 just yet. You can't mount two different ASM disk groups with the same name to the same server at the same time. Before we can mount our thin clone, we're going to have to change the ASM disk group names to ones that do not conflict. So let's change them to clone swing data and clone FRA. And to do that, we'll use the rename DG function in ASM. So let's do that next. I've logged into my target VM, Oracle 2. This is the VM we've mapped our thin clone to. First, let's check to see what Oracle instances are running. So, we have an ASM instance and we have a Swing instance, which is our existing Swing Bench database. Next, let's check the contents of Dev Oracle ASM to see what ASM disks we have currently. We're using udev rules to manage device names and permissions, although you could also use ASMlib or ASM filter drivers if you preferred. So we can see we have devices SDB through SDJ, and you can see that we have 4 disks for swing data and 1 for FRA. There's also 4 disks here for the data disk group, which is being used by a different database, so we're not going to touch that. Let's check the WWN IDs of the devices. Okay, you can see we have more devices. We have devices SDK through SDO, a total of 5 extra devices. We can also use this quick script to check sizes, and I'll post a link to it in the description. There's our 4 new devices, and the sizes match what we expected. 4 800GB volumes, which are the thin clone of swing data from Oracle 1, and a single 2TB volume for the thin clone of the FRA. So, let's make some new udev rules for these new volumes. You can see that devices SDK, L, M, and N are the 800GB volumes, so we'll call these clone swing data. I am going to use this quick helper script to create the rules. We'll make the owner grid and the group ownership will be ASM admin. We're using separate Linux user IDs for grid and the database. If you installed everything under a single user ID, then the owner would probably be Oracle and the group ID would likely be oinstall. We'll save the rules in etc udev rules.d and then make the rule for the clone FRA disk. Let's restart the udev rules processor and then check dev Oracle ASM directory to make sure our disks now show up. You can see that we've got 4 new clone swing data disks and 1 new clone FRA disk. Now we can log in as the grid user and use the rename DG command to rename our cloned ASM disk groups. We'll do swing data first, and we'll set the new name to clone swing data, and we'll set the ASM disk string to dev Oracle ASM clone swing data, so that it only finds the 4 new disks we added in the previous step. You'll notice that we have check set to true, which means that rename DG will check that the disk group can be renamed, but won't actually make any changes. Rename DG didn't find any problems, so now let's change check to false and do the rename for real. Rename DG has finished, there's no errors, and swing data has now been renamed to clone swing data. Now let's rename FRA to clone FRA. It takes about 20 seconds to rename an ASM disk group, but I'm going to use a little video editing to speed that up here. With both disk groups renamed, there's one last optional step we're going to do. We're going to mount the disk groups in a restricted mode and rename the disks. When you create a disk group with ASM, for example, data, ASM will name the disks data00, data01, data02, and so on. We're going to rename those disks to match the new disk group names. Now, this step's entirely optional, but we're going to do it just for completeness sake. The command we're going to use is alter disk group rename disks all, and with that done, all the disk names will now match the disk group. We can now unmount clone swing data, and then we can mount clone FRA and perform the same rename operation. After that, we can bring both disk groups online unrestricted, at which point the clone database files will all be available on Oracle 2. And that's all we have time for in this video. So as a summary, we created a volume group for all the ASM disks and disk groups for the Swing database on Oracle 1. We then created a Powerstore thin clone of the volume group. We then mapped the thin clone to Oracle 2. We renamed the ASM disk groups to clone swing data and clone FRA, and we renamed the ASM disks within each clone disk group. And finally, we mounted the clone swing data and clone FRA disk groups. In the next video, I'm going to show you how you can actually mount and open the clone database. I hope you found that useful, and if you liked it, maybe click like. If you really liked it, subscribe to the channel. And if you're feeling really daring, you could even check out the blog at graphdba.wordpress.com. Thanks everyone, and I hope to see you all again soon, before too long.